Johnny Dalton has a very big day ahead of him. He is vacationing on Ideal Island, where all gases behave ideally. Johnny and his family are going to start off the morning by scuba diving around the island. As we follow Johnny during his dive, we'll be paying close attention to the role that gases play in this activity. More specifically, we will be seeing how Boyle's law helps us explain and predict some of the behaviors of gases. Johnny puts on his wetsuit and tank and jumps into the water. As he lowers himself under the surface of the water, he feels a little pressure in his ears, so he plugs his nose and swallows to equalize them. The reason he is feeling that pressure is because the surrounding water is pushing in on his ear, and the deeper he gets, the more water pushes on his ears, which causes even more pressure to be put on his ears. As that pressure increases on the outside of the ear inside the ear gets squished and the volume inside decreases. The air doesn't go anywhere, it just gets squeezed together, which causes that uncomfortable feeling he had before he equalized. When a scuba diver descends, he will need to let some of the air inside the ear out, which reduces this pressure. This is usually done by pinching your nostrils and trying to blow gently out your nose. If you try it right now, you may hear a little popping sound. That's the sound of the air going in or out of your ear. Another thing Johnny notices as he descends is that his buoyancy compensator, which is just a vest filled with air, is getting smaller and smaller. Even his wetsuit is shrinking. What is causing this? Well, a scientist named Robert Boyle discovered that the pressure on a gas and its volume are inversely proportional to each other. This works for any closed system of gas, such as inside of your ear, the buoyancy compensator, or even the thousands of tiny bubbles embedded in a neoprene wetsuit. If the temperature is held constant, the pressure of a gas increases as its volume decreases.